All right, so when I'm looking at something like this problem right here, we're looking for doing the elimination method, which means I'm trying to eliminate one of the variables. I look at the x's and they are not, if I add them together, they're gonna actually be 6 x's. If I add these two together, they're gonna give me 7 y's. So that's not gonna eliminate. So my first step is to check to see if there's any opposite pairs, which there are not. My next step is to take a look and say, is there the same pair? And the answer is yes, there is a 3x and a 3x. So essentially what I can do is make one of them negative, and if I make that negative, then I can actually eliminate my x's. But I can't just do that obviously to one thing, so I'm gonna have to do that to the entire thing. So what I'm going to do is take this entire second equation and change all of the signs in the equation and make it opposite of whatever it is. So -1 times the positive 3x would give me a negative 3x. -1 times the positive 2y would give me a negative 2y. And then -1 times 15 gives me negative 15. So now that I have that, I'm going to add all these together. This is only one way to do this. You can do it other ways, but I'm just going to show you this way. So now what you basically have are these two equations. 3x plus a negative 3x is going to cancel each other out, leaving me with nothing. 5y plus a negative 2y is going to give me a 3y. And then 24 minus 15, or plus a negative 15, is going to give me 9. Then I would divide both sides by 3 to get y by itself, and I would get y is equal to 3. Now that I have the y value, I can go up to the original equations. It doesn't matter which one. And notice that I didn't cross this out very dark. I want to make sure that it's something I can read in case I wanted to use that as a substitution for the other variable. I am just going to use the top equation just because it's there. So we're going to plug in 3x plus 5. We are now going to we're going to replace that y with the 3 that we said it was. And then we're going to go ahead and solve. This becomes 15, so 3x plus 15 equals 24. Then we're going to subtract 15 on both sides, and that leaves me with 9. And 3x is equal to 9. Divide both sides by 3, leaving me with x equaling 3. So I do have both of my coordinates. I'm going to now write them in coordinate form, x followed by the y in a set of parentheses, and that will be my finalized answer. I am not going to show it, but you should always make sure you double check the other equation to make sure that when you plug the x and the y in for that second equation, that it also makes it true. If you'd like more questions like this, you can find them on my YouTube channel, You Want Algebra. Check all of my stuff out, in this case, in the Systems of Equations elimination section.